Dear students, let us continue our discussion with the application of nanotechnology in food industry and agriculture. So we we know that with more than 60% of population depending on agriculture for their livelihood, as well as developing innovative systems for monitoring environmental conditions and delivering nutrients or pesticides as appropriate, so that agriculture became the backbone of most of the developing countries. So all this means simply that most of the population, that is more than 60% of the world's population, is relying on the agriculture or agriculture related activities, because most of the nations in the world are still developing, okay, for which agriculture is the main sector of, okay, their livelihood and development, okay. And coming to nanotechnology, so nanotechnology can improve our understanding of biology of different crops and thus potentially increase productions or nutritional values, etc. In addition that nanotechnology, in addition to all these things, nanotechnology can offer various routes to get added values to the crops. Okay, this means that nanotechnology helps us in understanding the biology of crops, which help, by doing that, it helps us in increasing the productions as well as the nutritional values of the crops, and offers various routes so that the values of the crops will increase. So for example, particle farming. Particle farming is one such example which yields nanoparticles for industrial use by growing plants in specifically defined soils. For example, research has shown that alfalfa plants grown in gold-rich soil absorbs gold nanoparticles through their roots and accumulate these gold nanoparticles in their tissues. And finally, the gold nanoparticles can be mechanically separated from the plant tissue with the help of nanotechnology. Okay, and nanotechnology has also a great potential to revolutionize the agriculture and food industry with new tools for molecular treatment of diseases, rapid disease detection, improving the ability of plants to absorb nutrients, etc. For example, smart sensors and smart delivery systems. Okay, these smart sensors and smart delivery systems will help the agricultural industry to combat viruses and other crop pathogens. In the near future, nanostructured catalysts will also be available, which will increase the efficiency of pesticides and herbicides, allowing the lower doses allowing the lower doses to be used. Okay, this means that nanotechnology helps. Nanotechnology increases the efficiency of pesticides and herbicides and allows only their lower doses to be used for crop protection against pests in the near future. An agricultural methodology, an example, okay, so that is agricultural methodology widely used in USA, Europe, and Japan, which resourcefully utilizes modern technology for crop management, is is known as controlled environment agriculture. Is known as controlled environment agriculture. So similarly, till now we have discussed how what is the importance. I explained what is the importance of nanotechnology in agriculture, in agricultural sector, especially. Now coming to nanotechnology in food industry. Okay. Nano food. Okay. So coming to nano food is the one in which nanotechnology techniques or tools are used during cultivation, production, processing, or packaging of the food. The impact of nanotechnology in the food industry is growing significantly over the last few years, with the organization of various conferences dedicated to the topic and invitation of various consortiums for better and safe food. The concept is that thousands of nano capsules containing flavors or color enhances or added nutritional components such as vitamins would remain dormant in the food and only be released at the time of synthesizing food after consumption. And at last, nanotechnologists nanotechnologists are more active presently about the potential to change the existing system of food processing and to ensure the safety of food products, creating a healthy food culture. They are also interested of enhancing the nutritional quality of food through selected additives and improvements to the way the body digests and absorbs the food. Although some of these goals are far away, the food packaging industry already integrated the nanotechnology in different products. Okay, so this is about the role of nanotechnology in agriculture as well as food industry in brief. Now coming to nanotechnology, a role of nanotechnology in the environment. Nowadays, the environmental degradation is the biggest problem with many sources and causes. Environmental nanotechnology is considered to play an important role in shaping the current environmental engineering and science. Greenhouses can greatly reduce water use, land use, runoffs, and topsoil loss. Manufacturing technologies allow operations. Okay, manufacturing technologies allow those operations that pollute the environment and cause harmful effects. But looking at the nanoscale has stimulated the development and use of novel and cost effective technology for remediation, pollution detection, catalysis, and others. Especially the scarcity of water in terms of both quantity and quality poses a serious threat to the safety of mankind, which especially in developing countries. Nanoparticles used as a potent adsorbents, in some cases they are combined with magnetic particles to ease the particle separation and are used as catalysts for chemical or photochemical destruction of contaminants. There is a hope that nanotechnological applications and products will lead to a cleaner and healthier environment maintaining and re-improving the quality of water, air and soil. For example, nano-sized xenovalent iron. This nano-sized xenovalent iron is used for the removal of metals and organic compounds from water, and nanofiltration membrane also does the same thing. So we can also quote nanofiltration membrane also as an example here. And it is expected that nanotechnology can play a big role in providing clean water in an efficient and cheaper way. Various nanostructured materials have been explored for their use in sensors for detection of different compounds. Okay, this we already know. And nanotechnological approaches are continuously being examined to supplement traditional water treatment methods with lower cost and more effective than current techniques for the removal of contaminants from water. I repeat once again, nanotechnological approaches which are continuously examined to supplement traditional water treatment methods with lower in cost and more effective techniques for the removal of contaminants from water. The semiconductor titanium dioxide has been studied extensively for oxidative or reductive removal of organic pollutants. The implementation of green chemistry principles for the production of nanoparticles and for nanotechnological applications in standard chemical engineering will lead to a great reduction in waste generation. Okay. Less, apart from this, it also leads to less hazardous chemical synthesis, improved catalysis, and finally, an inherently safer chemistry. Pollution prevention by nanotechnology refers to, on the one hand, to a reduction in the use of raw materials, water, or other resources, and elimination or reduction of waste, and on the other hand, to more efficient use of energy or involvement in energy production. Okay, so this is the way, with few examples. Okay, we have discussed the role of nanotechnology in the environment. Okay, especially in the environmental production, for production of clean water, for reduction of pollution. Okay, and other things. So with this, I am concluding my discussion in this video. I will be continuing my discussion in the next video with other applications. Thank you.